Hey, what's going on, guys? It's Mr. Sanchez here coming at you with another lesson for pre-calculus. This time we're going to be covering the second half of section 2.4, part 2, which is piecewise defined functions. And our goal today is to graph piecewise defined functions, not only to graph them, but to analyze them as well. Okay? We're just going to have three quick examples and then we're going to call it a day. All right? So right here, you're gonna notice we're gonna have a piecewise defined function, and it's a little bit different than the functions we're used to. You're gonna get f of x is equal to this whole thing, right? It's equal to this whole thing. So what is this? What is this? All right. So it's called piecewise because you're chopping up the function into pieces. So for one half of the function, this function is gonna be 2x plus 3. Well, only if x is less than 0, so if x is negative. And for the other half, you're gonna have x equals to negative 1/2 x plus 3, but only if x is greater than 0. All right. So let's go ahead and answer the first question, which is to find the following values: f of -2, f of 0, and f of 2. All right. So we're gonna start with f of -2. To find out what f of -2 is, you have to plug in -2 for x. But you gotta wonder which question is it, this one or this one? Well, it's actually pretty simple. At -2 is less than 0. So you're gonna plug that into this part, right? Because this is if f of x is if x is less than 0. -2 is less than 0. So you're gonna plug that in. You're gonna get 2 times -2 plus 3. You're gonna get f of -2 is equal to -4 plus 3, which is -1. All right, we're done with that part. We're done with this one. Done. Now the next one, f of 0. You're gonna plug in. It's the we gotta look at our at these inequality parts because x is not greater than If you notice here that our function is defined when x is less than 0 and when x is greater than 0, but none of them have the or equal to sign. I don't see no equal to sign here or here. So because it does not there is no part of this our definition that has greater than or equal to or less than or equal to. We're gonna say that the f of 0 does not exist. Okay, it does not exist. All right, now we're gonna do the last one, f of 2. So f of 2, we're looking for the part where x is greater than 0, right? So we're gonna plug it into this equation right here. We're gonna have -1/2 times 2 plus 3. -1/2 times 2 is -1 plus 3, which is going to give us +2. So we're gonna have f of 2 equal to 2. Okay. Next, our final thing we're done with this example is we gotta graph our function, right? So let's just go ahead and graph this. Pretend it's a slope intercept form, but but we're only gonna notice how it says only when x is less than 0. So it is a slope intercept form, but because we're gonna start with the y-intercept, that's when x equals 0. So normally it would be 3, but because we do not have the or equal to, we're gonna have an open hole at 3. 1, 2, 3. So we're gonna start here with an open circle, and the slope is 2, so we're gonna go down 2 over 1, and then down 2 over 1 at 2, and then it's gonna keep going down in that direction. And because it's gonna keep going down in that direction, we're just gonna have an arrow saying we're gonna keep going down that way. The next set, this is 2x plus 3. Right. Next, we're gonna try and graph -1/2 plus 3. X plus 3, right? So once again, we start with a y-intercept, which would normally be 3, but for some reason doesn't have an equal sign. So we're gonna have this hole, and then our slope is -1/2. So we're gonna go down 1 over 2, down 1 over 2, and it's gonna keep doing that forever and ever. So we're gonna connect the dots and draw our graph like that. Ta-da! And that's basically how we do our first problem, right? Sometimes you have a piecewise defined function that has a limited domain and range. When this one, it has a limited range. I mean, domain. It has an unlimited domain with a limited range. Let's go on to the next problem. All right, next problem you're gonna notice that our piecewise defined function is actually defined by 3 parts. Right, so there's 3 parts to our function. There's negative 2x plus 1 and f a negative 3. If x is that greater between negative 3 and 1, greater than it's going to be 2 if x equals to 1, and it's going to be x squared if x is greater than negative 1. The first question says determine the domain. So our domain here is going to be from negative 3 to infinity. It's kind of hard to tell without looking at the graph, but if you look at this part right here, this is basically our domain, right? Our lowest point is going to be negative 3, and we're equal to it. And then you're going to see it's going to go from negative 3 all the way to 1. Then it's going to be at 1, it's defined. And then right here, it's going to say we're going to keep going bigger than 1. So it's going to have a lot more than just the usuals. So that's why our domain is negative 3 to 0. To find any intercepts, all right, how do we find our x-intercept? That's when x is equal to 0. Our y-intercept, that's when x equals 0, right? Let's try to find our y-intercept. We're going to plug it into this one right here because 0 is between negative 3 and 1. So let's go ahead, negative 2 times 0 plus 1. That's going to give us 1. So we have a y-intercept of 0, comma 1. As for our x-intercepts, we don't have any. The reason we don't have, and we'll come back to this. But first we're gonna graph it, and I'm gonna tell you why we don't have an x-intercept. It'll be a lot easier. So let's start with negative 3, right? We're gonna have negative 2x plus 1. We're gonna start at negative 3. Negative 2x plus 1. That's gonna be negative 2 times negative 3 plus 1. It's gonna be 6 plus 1, which is 7. So a negative 3 should be 7. 1, 2, 3, 4, 5, 6, 7. Right, and our y-intercept should be 1. 1. Right, and our slope should go in negative 2, so it's down 2 over 1, down 2 over 1, and just like that. Ta-da. That's why we don't have a. Okay, and now you're probably thinking, well, we have an open circle there, mister. Why do we have a slope? All right, so if x equals to 1, we have our value of 2. Oh my gosh, I'm sorry, guys. That's where I made a mistake, guys. Remember, it goes to 1. So we do have a hole here, and you're gonna keep going. This is gonna have a hole here. Ta-da. All right. But remember, we have a hole here because at x equals 1, we're gonna have the value, our y is gonna equal to 2 right here. If x equals 1, y is 2. And when x is greater than 1, we're gonna have x squared, right? So let's plug in some values. So out of 1, we still need to know what happens at 1. At 1, it's 1. So normally you'd want to start here. And then at 2, you're gonna have 4. Right, so at 2, you're gonna have 4. So 1, 2, 3, 4. And then you know it's a parabola, so you know it's gonna go up. So it's like if you drew the parabola going up like this. Right, it's like you drew the parabola going like that. However, you're just gonna connect this point, these points like this. You might want to curve it more than I did. I didn't really curve it. Let's see if I can get. Let me see if I can get it. There we go. And that's how you graph it. So you're gonna notice we do have a x-intercept. My bad. That's my bad. And that's whenever we let this part equal to 1, equal to 0, right? So you gotta, to find it, you're gonna get negative 2x plus 1 equal to 0 minus 1. You're gonna get x is equal to 1/2. Okay, if you do the work. So we're gonna have it when at 0, 1, and at 1/2, comma 0. We did the graph, and you're gonna notice that for our range, we go from negative infinity. Oh, no, that's not true. Okay, so for our range, our lowest value is going to be negative 1. We don't actually touch negative 1, so we're gonna go from negative 1, and our graph will go along forever and ever upward. So it's from negative infinity to infinity. All right. That's our range. One last thing before we're done. All right, guys. And it's to graph. We're gonna graph. They give us a graph, and we need to find the definition. All right. So right here, I can look at this graph. I can. It's very easy to tell that our slope is -1, and we have the point 0, 0. Since we have 0, 0, we can use that in point slope form. All right, 0, 0, and that's gonna be y minus y1, right? Y minus 0 is equal to -1, x minus 0, which means we're gonna get y is equal to -x. And that's true for our function, but that's only true from -1 to 0. So we're gonna write if x is in between, is less than or equal to 1, -1, less than 0. All right. Remember, you don't put y anymore, so we can just take off the y. And then our final part is going to be, you can see right here, our slope is 1/2 x, 1/2, right? And our y-intercept, m is 0, and our y-intercept is 0. So if we're using point slope intercept form, you're gonna get that it's 1/2 x if x is greater than 0 or equal to. And say or equal to because you have a solid line. It doesn't matter which one you said equal to, but yeah. All right, guys, that's basically it for today. If you have any questions, please feel free to let me know in class. And yeah, that's it. All right, guys, have a great day.